Welcome again to Sir J Maths channel, Maths Made Simple. Now here we'll looking at our third video, doing our third video. And so without further ado, let us go. Now we know that 35 squared is really 35 times 35. And if you are going to work it out, you could do this. So we get 5 5 is 25, 5 carry 2, 5 3 is 15, and 2 is 17. 3 5 is 15, 5 carry 1, 3 3 is 9, and 1 is 10. Now we put the digits under the correct digits. So we have 5, 7 and 5 is 12, 2 carry 1, 1 and 1 is 2, plus 0 is 2. And then here we have 1. Now this is 1225. So here we realize that our product actually ends with 25. So if we go to 35 squared, we know that it must end with 25. So the short way of arriving at 1225 for any numeral that ends with 5 that is squared, you basically look at the digit or even the digits that come before the 5, and all you simply do is to just multiply that digit, or basically numeral, times the numeral in front of it, which is 1 ahead. So we know that 4 is 1 ahead of 3, so we simply say 3 4s is 12, and that is our answer, as in 1225. So let us look at another one. If I have 85 squared, I know that it must end with 25. Good. So therefore, it's 8 times the number 1 ahead of 8 is 9. So 8 9s is 72, and this is our answer, 7,225. Even if I have another one, 105 squared, I look at these two digits, which give us 10. We know that 5 squared is 25, and then 10 times 11, 11 times 10, basically, we'll get 11 ones is 11, and we join the 0, so what we get is 11,025. Now, here we have this question, given that x equals -4, what is the value of 3x squared plus x minus 5? And so, here we have the choices A, -57, B, -33, C, 43, D, 39. For this question, you definitely need to substitute the value of x into the given expression. Now, this is an algebraic expression, a quadratic expression, which is also an algebraic expression, which is also called a trinomial. The reason it is a quadratic expression is because the highest power of the unknown, and the unknown here is x, the highest power is actually squared, and that makes it a quadratic expression. The general form of this is actually ax squared plus bx plus c, in which a is a coefficient of the squared term. So a here is +3, b here is a coefficient of the unknown raised to the power of 1 here, or to the first power. So b clearly here is 1. It's called the hidden coefficient. And c is -5. So what we are going to do is to substitute -4 into this expression. So you write 3x squared. No, 3x squared means 3 times x squared. So it's times x, but x is now -4 squared. So it is not 3x squared, because 3x squared is different, is not equal to 3x. This actually means 3x all squared, where what you'll have to do is to multiply 3 to the value of x, then you square the product. We have 3 times -4 squared plus x, which is -4 minus 5. So what we need to do is work out -4 squared. Now, as long as -4 is in a pair of brackets and you square it, then what this means is that it is -4 times -4. And based on a previous video, we know that when we multiply two quantities with the same signs, the result has to be positive. So this is 3 times +16. So it's 3 times +16 being added to -4 followed by -5. Now what this is saying is that, okay, -4, -5, these two numbers clearly are to the left of 0 on the number line. can look at it as 04 to about 5 more in all is 9. So it's plus negative 9. Now 3 times 16, basically 3 sixes is 18. You write down 8 carry 1. So you don't necessarily need to write down everything. You can use your head. 3 sixes is 18, 8 carry 1, 3 ones, 3 and 1 is 4. So what I have is 48 plus negative 9, which is the same thing as 48 minus 9. And when I take 49 from 48, is, let us say you have 48 and you owe 9, pay the 9, 48 minus 9, 9 from 8, you can't go over here, take 1, leave 3, put it here, 9 from 18 is 9, so what you have left is 39, and then you look to see if you have your answer, and D is our answer. For this question, this is read as 2a squared b all cubed, or raised to the third power. Now, clearly, what we need to do is to look at each item inside here. So this is 2. So here we have a base of 2. But in index form, the quantity also has a power. So if you don't see a power, we know that the power here is actually 1. So this is 2 raised to the power of 1. And 2 raised to the power of 1 will actually be cubed. So when we raise a power to another power, the rule is that we multiply the powers. So it's 2 raised to the power of 1 times 3. So base power raised to the power, we simply multiply the powers. Base here is A, its power is squared, it's going to be raised to the power of 3. Again, we multiply by 3. Base here is B, power is 1, which is called the hidden power, raised to the power of 3, we multiply by 3. Now 1 times 3 is 3. 2 to the power of 3 means 2 times itself 3 times, which clearly gives us 8. A squared, 2 times 3 is 6, so we have 8 to the power of 6. 1 times 3 is 3, b to the power of 3. So what we actually get is 8a to the power of 6b cubed. Immediately you glance up here and you see that it is b. Your answer is b. The mean of the scores 3, 5, 8, 9, and 10 is. Now, based on a previous video, we said that mean basically refers to the sum of the values divided by the number of values. Now, how many values do we have here in this distribution? We have 1, 2, 3, 4, 5. So we can look at mean as the sum of the values divided by the number of values. But in a multiple choice exam, you basically write out this formula. I'm just writing it out to show you what you are actually doing. So all you simply do, you just write mean, you just add up these 5 numbers, 1, 2, 3, 4, 5. So let us go to work now. In our head, based on what we talked about before, we can say 5 plus 3 is 8. Now we are now adding 8 plus 8. That's 2 sets of 8. 2 8s is really 16. So now we have 16 plus, say, 10. We can say 16 plus 10 is really 26. So that is now 26 being now added to the 9. So here I can say 9 and 6. I can take 1 of the 6 and put it on the 9, make 10. And 5 is left. So 10 and 5 is 15. 5 carry 1. 2 and 1 is actually 3. So what we get here is 35. So that is actually the sum of the values, or what we call the aggregate. Now we are going to divide the aggregate or the sum of the values by 1, 2, 3, 4, 5 by 5. So we divide 35 by 5 and we are doing it quickly. Now you need to know your timetable. 5 into 35 goes how many times? Now here we are divided, but to divide you also need to know to multiply. So 35 over 5 equals to what? In other words, 5 times what give us 35? So 5 times 7 is 35. So if you know how to multiply, you automatically know how to divide. So our answer clearly is 7. Here we have the value of 0.386 times 0.06 is. Now, not everything in the multiple choice you have to work out. Now, when we look at this figure is expressed to 3 decimal places meaning that there are 3 digits behind the decimal point. This figure is expressed to correct to 2 decimal places, meaning that there are 2 digits behind the decimal point. Now, usually, if we are going to multiply a 3 decimal place figure by a 2 decimal place figure, then the product will be represented as the sum or as having the sum of the decimal places. So when I add 3 plus 2, I actually get 5 dp. So usually the product would have 5 decimal places. So let us check. Let us look at D. This is expressed to 2 dp. C is expressed to 3 dp. B is expressed to 4 dp, while A is expressed to 1, 2, 3, 4, 5. So clearly this is our answer, and you just circle A without even having to work out anything. No, number 90 is clearly related to what we just what we have just done. So the result of 15.96 times 23 correct to 2 significant figures is. Now again, we don't necessarily have to work out this, because this is 15, so the whole number right here is 15. Now clearly, if we were to round off this to the nearest whole number, then this would have been 16, because we'd have looked at the 10th position, and because the digit in the 10th position is 5 or more, it would have increased the unit's position by 1. So this would clearly be 16. So here we would have 16 times 23. Clearly, a 16 times 23 could never be 0.37. So this is out of our answer. This cannot be the answer. 16 or 15 times 23. Clearly, it cannot be 37. Because imagine 15 times 2. We know that 15 times 2 is already 30. So if it is 23, it's 10 sets of 2 that actually give us 20. And that is really 23. So clearly 37 cannot be our answer. Now let us look at C. It says here correct to 2 significant figures. Now when we check D, we have 367.08, but this is expressed to 1, 2, 3, 4, 5, because we said that the 0, once it comes between any 2 digits that are significant, is also significant. So because we want it to 2 significant figures, clearly our answer is C without working it out, because the 3 and the 7 are the only 2 significant figures here, because the 0 here is not significant because it is on its own. No, it is of note that even though it is not significant, it is important in that it holds a place value. This suggests that there is 0 units, 7 tens, and actually 300. So you cannot remove the 0 from this. It will change the value of the numeral. Okay, CXC students, some of you basically have a problem with adding even in your head. Now we know that 70 plus 3 is 73. So 70 here is a multiple of 10. So any multiple of 10 along with a single digit, you basically just join them. So 70 plus 3 is 73. 80 plus 9 we know is 89. Now the issue arises whenever you have something like, say, 79 plus probably 8. Some of you guys beat your chest and you count your fingers, but all you simply need to do is to allow 79 to become a multiple of 10. So you round it up to the nearest multiple of 10, which gives us 80. And we want 1 on the 79 to give us 80. We'll have taken 1 from the 8, leave 7. So you simply say 80 plus 7 gives 87. Now what if you have like 68 plus, say, 5? Now again, you do the same thing. You round up the 68 to 70. So we want 2 from the 5 to put on the 68, give us 70. So you'll have removed 2. You'll have removed 2 here, leaving us with 3. So now it's 70 plus 3, that gives us 73. Now, what is the least number of operas? Least number of operas that can be shared equally among either 6, 8, or 12 children? As soon as you see this question and you see least, what should come to your mind is, okay, lowest common multiple. In other words, what is the smallest number of apples that can be shared equally? among whether you have 6 children, whether you have 8 children, or 12 children. Now what this simply requires is for you to find the LCM of 6, 8, and 12. So what you do, you write down 6, 8, 12. Now how do we find the LCM of a set of numbers? Now what you clearly do, or what you can do, look for the largest or the larger number in that set. And so clearly the larger number here, the largest number here is 12. Then you check if the others can go into 12. If they can go into 12, 12 is our LCM. Now 6 can go into 12 exactly, but 8 cannot. Now how do we find the LCM then? Now the LCM must be a multiple of 12. It isn't 12, but it must be a multiple of 12. So what we can do is to double 12, which is our second multiple, that gives us 24. Then we check, can 6 go into 24 exactly? Yes, 4 times. Can 8 go into 24 exactly? Yes, 3 times. So hence 24 is our LCM. In other words, if you have 24 apples, whether you divide, whether you have 6 children, you can actually share that 24 apples equally among those 6 children, in which each child will get 4 apples. And if there are 8 children, then each child can get 3 apples equally. And if there are 12 children, then those 12 children can get 2 apples equally, or equal share. And that's what it means. Now for this question, in the parallelogram WXYZ above, so you have learned about a parallelogram before. So with the parallelogram, we know that this length, this side is opposite and parallel to this one, and they're actually equal in length. And this side and this side, they are actually parallel and equal also in length. Now, in the parallelogram WXYZ above, now it is of note, I can add right here, that remember that this vertex and this vertex, they are opposite vertices. This one and this one, they are what you call adjacent vertices, meaning that they are found on the same line. Now, so this vertex and this vertex, opposite vertices. So when we draw a straight line here, what we actually get is a diagonal. Another diagonal can be drawn from here. So 2 diagonals are basically in any quadrilateral. Now, what happened here with a parallelogram is that opposite angles tend to be equal, and the diagonal here tends to actually bisect each angle right here. And also the 2 diagonals tend to meet at right angles. Now, here it says WXYZ. So you read WXYZ above. R is a midpoint of XY. So right here is R, which is a midpoint. Now when we say midpoint, it simply means that R lies exactly halfway on XY. Now it says determine the vector ZR. So here, based on what we learned before, that the vector begins at Z and actually ends at R, because the tip of the arrow is at R. So what we want is actually vector ZR, that is from here to here. So you can do something like this. Now Z going to R. Now before we even look at this, let us see how best we can work out something here. Now ZR, we can actually, let us say these are 3 terms, Z, Y, and R. And you want to find ZR, or you want to travel from Z to R. Now the easiest way is basically a straight line from Z to R. Good, so you want to find this. But then we don't have a definite way of finding, of going from Z to R. So what you have to do is to go all the way around here, which is the alternative route, or the alternate route. So we go from Z to Y and from Y to R. So we'd go in this direction, Z to Y and Y to R. Now, let us reflect on something. Now, if on a parallelogram, if WX is 6 centimeters, so let us say that is 6 centimeters, then ZY is also 6 centimeters. So it follows then that ZY is the same thing as WX, as long as it is going in the same direction. So what we have here is ZY, so vector ZR, let us work it out, ZR equals, we are going from z to y, so we first write out z to y, and then when we reach at y, we now go to r, then from y to r. But it follows that vector zy is the same thing as vector wx. So where we have zy is the same thing as vector wx plus, now y going to r. Now let us examine something. We know that vector xy then, that is going in that direction, is the same thing as vector wz, which is going also in the same direction. So vector xy and wz are equal vectors. They are basically the same. Now, if r is a midpoint of xy, then r is also the midpoint of wz. So r, let me put it up here, that basically, let us have, say xr, vector xr would be actually half of vector xy. And also ry, vector ry must also be half of vector xy. But we are moving from y to r. Now, what is the relationship between vector ry and vector yr? So if you notice, ry is going in that direction, while yr is going in the opposite direction. Now, remember we said that basically they would have the same magnitude, but they are going in opposite direction. And so we have to take into consideration that vector yr is essentially not exactly the same as vector ry because of the opposite direction. And so vector yr is the negative of vector ry. So since vector ry is half of xy, then yr must be the negative of vector ry, which is, we have vector wx, and then plus negative of ry is actually the negative of a half of vector xy. And then we check to see if that answer is there. But xy, remember, is the same thing. Now when we check, we have wx, which is vector wx minus a half of wz. But remember, we are saying that xy is the same thing as wz. So we always simply need to do is to replace vector xy with wz. And here, our answer clearly is B. So here we have vector questions. If the vectors p and q are 3, 2 and negative 1, 4 respectively, then negative p or minus p minus 2q is. Now you need to know that a vector basically is a quantity that has both magnitude or size and direction. And a vector, vector p is usually probably written like this, or it can be written, say, with 2 capital letters as, say, even AB. And what normally happens is that here the arrow, it shows the tip of the arrow and the tail, simply meaning that the vector actually begins from from the tail, to the tip. So it moves from A and go towards B. Now if you were to draw this, you'll have P vector 3, 2. So if this is the origin right here with coordinates 0, 0. So 3, 2 is like 1, 2, 3, 2. So this is where you would have vector P as 3, 2, although it can be represented as a free vector. So this clearly is a free vector. So we can have 3, 2, meaning we have 1, 2, 3, and we go 2, 1, 2 places up. So that can be our vector, and we can call that vector P. And we can have vector Q as negative 1, 4 as a free vector. We move 1 place down, 1 place across, and 4 places up. Sorry, we go 1 because it is negative 1. We go 1 to our left, 1, 2, 3, 4 places up. So our vector clearly would look like that. So what we have right now is that here we see that the negative sign is on the outside. And once you have a negative sign on the outside, clearly this negative sign will change the sign on the inside here. So this becomes negative 3, this becomes negative 2. And negative 2 times a negative 1 will actually give us a positive 2. And a negative 2 times a positive 4 will give us a negative 8. Now, when we are adding two vectors, xy, or x1, y1, plus say x2, y2, because vectors are always written in column form, while coordinates are written in horizontal form. So if you have the point 3, 2, then that point is written as 3, 2 in horizontal fashion. But if it is a vector, it must be written in a column form. So what happened here? These two elements are actually corresponding elements, meaning that they are in a similar position. So what we are going to do here is, in finding the sum of these two vectors, we add corresponding elements. So we add x to x, negative 3 plus 2, we owe 3, we have to pay the 2, sorry, we are going to still owe 1. Negative 2 plus negative 8, we owe 2, we go back, we owe 8 more. In all, we owe is 10. So that's negative 10. And we look to see if our answer is there. Yes, our answer is D. And that is it. We have our answer. Now, with this question, you see if, and then what you see here, you see A, and then you have two lines like this at the side of A equal to 0, then A is. Now, remember we said that mathematics has its own language, and every topic also has its own language in mathematics. Now, whenever you see this in maths, it usually signifies the determinant of a matrix that is called A. So this is a determinant of matrix A. Now, let us say we have a 2 by 2 matrix, and we write it as, say, 2, 3, 4, 5. Now, when you say a 2 by 2 matrix, what exactly is a matrix? A matrix is an array or an arrangement of numbers in basically what you call rows and columns. So 2, 3 would be our first row, 4, 5 is our second row. So this basically has 2 rows, and then 2, 4 is our first column, 3, 5 is our second column. So we actually refer to this matrix as having a 2 by 2 matrix, which is also called a square matrix. So when they are asking you about the determinant of matrix A, a 2 by 2 matrix can be written in the form A, B, C, D. And it is of note that we can use curved brackets to enclose the elements or members of the matrix, or we can actually use square brackets. Whichever you use, it doesn't really matter. So this is A, this is B, this is C, this is D. So basically the determinant of a matrix is given as AD minus BC. Now if we look at a square as a quadrilateral having 4 equal sides, then clearly we know from previous information that if we draw a line straight from this vertex to its opposite vertex, then this is a diagonal, and then this is also a diagonal. So what happened here, what I've just done, is actually representative of a diagonal. But we refer to the diagonal that runs downwards from left to right as our main diagonal. This is AD minus BC, which actually represents our determinant. So remember, we can have determinant A for short, or we can actually use this with the 2 lines or the 2 line segments here at the side of A. So if matrix A equals A, B, C, D, then det A, or the determinant of A, actually equals to AD minus BC. Now, let us go to the question itself. I was just giving you an overview of what determinant really is. So it says if the determinant of matrix A equal to 0, then A is. Now, here we have an inverse matrix. Now, an inverse matrix, if A is our matrix, then we write the inverse matrix as A to the power of -1, which is A inverse is actually 1 over the determinant times what you call the adjoint matrix. Now in the next video, I'll be looking at the adjoint matrix, basically with some questions times the adjoint matrix. Now if we have an inverse matrix and we have 1 over the determinant here, then if this is 0, if the determinant equal to 0, now please look, if the determinant is 0 and we divide 1 by 0, we know that this is not possible because this is undefined. So if the determinant of a matrix is 0, then it will not have any inverse, and so it cannot be an inverse matrix. And so what we really call it is what we call a singular matrix. So a singular matrix is any matrix that has a determinant of 0 and it will not have an inverse. Now here you see identity matrix. What exactly is an identity matrix? Now the identity matrix is one, if we are looking at a 2 by 2 matrix as having 1 0 0 1, and it is always denoted by the letter I. Now if you multiply a matrix to its identity matrix, we basically get back the matrix itself, or even multiply the identity matrix by the matrix, we get the matrix itself. So if I have A times the identity matrix, I will get back the identity matrix. I will actually get back matrix A. Now a non-singular matrix is a matrix in which the determinant is not equal to 0. So clearly our answer is B, a singular matrix. Now here we see that X equals, now once you see the square brackets here, it suggests that this has to be a matrix. So this is matrix X equals 1 3 negative 3 3 0 5. Now note we read the matrix in terms of the rows. So it's 1 3 negative 3 3 0 5. Y equals 3 0 2 1 and 0 5. Now what is the order of the matrix product XY? Now XY. Now let us, for you to know the matrix product for two matrices, we first need to know the order of each matrix. Now let us look at matrix X. Now the order of a matrix, if you can remember, is basically determined by the number of rows times the number of columns. So how many rows do I have here? I have 1, I have another one here, so that's 2 rows. So the order of matrix X basically is 2 rows times how many columns? We have 1 column here, another one here, another one here. So clearly the order of matrix X is a 2 by 3. So I write here 2 by 3. Okay? And this is matrix X. Now let us look at matrix Y. There are 1, 2, 3 rows. And how many columns? 1, 2. So this matrix for Y is a 3 by 2 matrix. Now, in order for 2 matrices to be multiplied, they must be compatible. Now, when we say compatible, what we actually mean is that the number of columns in the first matrix, so our first matrix is X, the number of columns in the first matrix here is 3. And the number of rows in the second matrix here is 3. So in fact, for them to be compatible, for them to be multiplied together, then this number and this number must be equal. So in other words, all you need to do is to line up the order of the 2 matrices, check to see if these 2 inside numbers are the same. And if they are the same, then they can be multiplied. Now the order will basically be the 2 numbers, the product of the 2 numbers outside, or the order of the 2 numbers outside, which is a 2 by 2. So our matrix will have a 2 by 2 order. This is the end of video 3. Stay tuned for video 4. Now, I've been getting support from you guys and I really appreciate it. Let us work together so that we can make maths simple for everybody. Now, in the next video, we'll continue to look at some more vectors and matrices question, as well as other topics that will be coming on the exam. No, I want you to get excited because you can pass this exam. Okay? So continue to share the video, continue to tell people about it, subscribe, and as usual, I do appreciate what you are doing. Thank you very much.